How do I read data from a file into an array of objects? Can I sort an array of objects? Can I search in an array of objects? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 45th video in the Introductory Programming in Java full course, and the 6th video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In prior videos, we looked at arrays, arrays and methods, reading into an array from a file, and searching and sorting algorithms. In all of those examples, our arrays were filled with primitive data types. We then looked at how to fill an array with objects. In this video, we're going to look at how to fill an array with objects created from data in a file, and then search it, sort it, and as a bonus, we'll do a fun choropleth map example using our objects. Let's get right into it. This file is called countryrights.java, and this is the class that defines the objects we're going to store in our array. The data for these objects comes from Our World in Data, the LGBT plus rights section. This data is originally from EqualDex, with major processing from Our World in Data. I'll put a link in the description. You can see on the Our World in Data page that the data is used to color in a map, showing countries with low scores on the equality index in red colors, moving through the rainbow up to purple for countries with a high equality index. We'll do something similar at the end of this video, but we'll use a single color with different levels of transparency representing the equality index. And here's the data I downloaded. What I downloaded is a CSV, a comma-separated values file. You can see there's a country name and then a country code. These codes follow the ISO 3166-1 Alpha 3 standard. It's good to have a standard like this so you can merge tables of data based on those values. If two tables use the standard, and the country code from one row in one table matches the code from another row in another table, then the data in each row is describing the same country. We'll be combining data that includes the country code and country borders for our map with our object data that will include the country code and equality index. The next value in each record is a year, and finally the equality index, which is a calculated value from 0 to 100, with 0 representing the lowest level of LGBT plus rights, and 100 representing the highest. Now, I've restructured that data a little for our program. The file we'll work with is called LGBT Legal Equality Index Modified.txt, and here it is. I've removed the headings line, and I put each data element on one line. Every 3 lines of this file is one record. You can see country name, Afghanistan, followed by the code, AFG, followed by the equality index, 0. I've removed the years because the original file contained only data for the year 2024. So after the equality index, then the next country name, code, index, etc. through the end of the file. I've also removed the continent and world summaries, so there is only country data in this file, and each record is complete. This kind of cleanup is called data wrangling. It's a common step when working with real-world data because raw data is almost never ready to use right out of the box. This data was not raw. It was beautifully structured by Our World in Data, but it wasn't perfect for our application, so the wrangling was relatively minor. All right, let's look at our program now. We'll start with the country rights class. It has 3 private fields, one for each of the pieces of data in the file for each country, the country name, the country code, and the equality index. And we have a constructor that takes the 3 parameters and assigns them to the fields. Now the rest of my methods are designed to make this object useful to the programs I want to write. We have no straight-up setters, there's no way to change any of the fields, and there's only one getter, a method that directly accesses a field. We have getName, which returns the country name. We have a compareTo method that takes another country rights object as a parameter. It returns a positive value if the object receiving the message has a higher equality index than the object passed as a parameter, a negative value if the object receiving the message has a lower equality index than the object passed as a parameter, and 0 if the 2 objects have the same equality index value. We do this by returning the equality index of the object receiving the message minus the equality index of the object passed as a parameter. Remember that you can access private fields of a country rights object within a country rights method, even a country rights object that isn't the object responding to the message. That's how we can write copy constructors and methods that compare objects. So if I send this message to the Afghanistan object, and I pass the Albania object as a parameter, the method will return 0 minus 62.27 or negative 62.27. A negative result means Afghanistan's equality index is lower than Albania's. If I send this message to the Albania object and pass in the Algeria object as a parameter, the method will return 62.27 minus 3.42, or 58.85. A positive result means Albania's equality index is higher than Algeria's. This is how compare to works for string objects. The next method is country. It takes a country code as a parameter and returns true if it's the code in this.code and false otherwise. The next method is getAlpha. This method scales the equality index to an alpha value, which is a transparency value for RGBA colors. The transparency value for RGBA colors is a number between 0 and 255, with 0 being fully transparent and 255 being fully opaque. A country with a higher equality index will return a more opaque alpha result and will therefore appear darker on our choropleth map. And finally, there's a toString method, which simply returns a formatted string of the values in the fields. Now we know what our file looks like and what our objects will look like. Let's look at a program that reads the data from the file into our objects in an array, then searches the array, sorts the array, and then displays the countries with the lowest and highest equality index, followed by a list of all countries ordered by equality index. This program is called countrywritesprogram.java. We begin by creating a file object to reference our text file of 3-line country data records on line 22. We then create an array to hold our country rights objects on line 23. Let's review that syntax. The data type is country rights open close square bracket, meaning an array of country rights objects. The variable name is countries. Then equals new country rights open square bracket 192 close square bracket. I know there are 192 country records in the file, so this line creates an array of exactly the correct size. After this line executes, the array will contain 192 null values. After we create the array, we have some file reading code that should look familiar. We check if the file exists. If it does, we create a scanner to read from the file. We then loop over the file with 2 conditions, while there is still data in the file, and we haven't reached the end of the array. In the loop, we read the 3 data elements, each to a line, that make up a single record, the country name, country code, and equality index. We consume the new line that is left in the input stream after reading the equality index, so it doesn't cause trouble when we loop again and read the next country name. At this point, we have all of the data that we need to instantiate a country rights object, so we create an object and store it in our array on line 39. Countries sub I++ equals new country rights name code equality index. Let's break that down. This is an assignment statement, so we'll begin on the right. We just read name code and equality index from the file. We are passing those as parameters to the country rights constructor. The new keyword creates a country rights object in memory, and the constructor is then invoked, assigning the values we just read from the file to the fields of the object. We then store that in the next location in the array, countries sub I. And after I is evaluated, it is incremented, so it will index to the next location in the array the next time through the loop. We have read and processed records from a file before. Now, instead of processing the record, we're storing it in an object in an array. Once the array is full, we can process it. It is currently alphabetical, as that is how the data is stored in the file. So now, while it is alphabetical, we can use a binary search to quickly find a specific element in the array by country name. What I have in this program from lines 46 through 77 is our binary search algorithm, almost identical to the binary search code from our video on sorting and searching arrays. The difference here is that we're searching an array of objects and not primitives, so we can't directly compare what we're looking for to the value in the array. We have to take one additional step. We have to ask the value in the array, an object, for the value to compare. Let's look at how we do that. To start, on lines 46 to 49, I'm asking the user for the name of the country they want to search for. After that, on lines 52 through 70, we have the binary search. Recall that the binary search is going to find the middle of the array and see if our element is there. If it's not, it's going to look in the right side if what we're looking for is larger than the element at the middle, and in the left side if what we're looking for is smaller than the element at the middle. Now repeat that until you find the object, each time treating half of the remaining array as the whole array. So find the middle, look for the element, and then search in the top half or bottom half, depending on how the element we're looking for compares to the element at the middle. We're still maintaining 3 indices, left, middle, and right. On line 58, I have the code string name equals countries submiddle.getName. That's really the only difference searching an array of objects versus an array of primitives. The element at middle is a country rights object, so I can't compare it directly. I have to send it the getName message so I can compare its name to the name I'm searching for. And then, because this is a string, I must use dot equals and dot compare to compare. I can't use the relational operators. If I run this and search for a country, let's search for the United States. I get the United States data. Then there's a lot more because I'm about to sort this array, print the highest and lowest equality index countries, and then print all of the countries ordered by equality index. Let's look at that code. On lines 83 to 97, I have our selection sort code from the searching and sorting video. But again, we can't directly compare values in the array because values in the array are objects. We have to send them messages to compare them. Here I'm sending the compare to message on line 90 because I wrote the compare to message to compare the object's equality index values. This is a little different from the search above where I got the name from the object and then compared the name here in this program. For the sorting code, I'm taking the 2 objects I want to compare by equality index and sending the compare to message to one, passing in the other as a parameter. The object will compare itself to the parameter object and return a negative value if it's smaller, and a positive value if it's larger, and 0 if they're the same. So I'm testing the comparison against 0 and replacing the index of smallest if the country being compared is smaller than the country at the current smallest index. I thought it would be interesting to do the comparisons in these 2 different ways. It's useful to write compare to methods for our objects if we're going to compare them, particularly if the comparison might be complicated, as it is with strings. That's the approach I took with the equality index comparisons. But the other option is to have an accessor, a getter, that returns a value from the object and lets the outside program do whatever it wants with that value, such as compare it to another value. That's the approach I took with the searching code, where we're not comparing the names of 2 country rights objects, we're comparing a string obtained from the user to the name of a country. The final code in this program prints the country at index 0 in the array. Once sorted, that will be the country with the lowest equality index. It then prints the country at index length -1 in the array, which will be the country with the highest equality index. And finally, it prints all countries in the array, now ordered by equality index. Now let's take a fun side trip into the unfolding library, which will allow us to create a choropleth map of our data without needing to build a graphical user interface from scratch using something like JavaFX. To use this library, I had to download 2 things: Java OpenGL, JOGL, which unfolding uses for rendering the map, and the unfolding app template for Eclipse, available on the unfolding website. I'll include links to both of these in the description. For Java OpenGL, I downloaded the file named jogampallplatforms.7z, which contains JOGL, Java bindings for OpenGL. I extracted the contents of that file and also unzipped the unfolding app template folder, which is called something like unfolding app template with examples. I placed the JOGL folder somewhere convenient on my system, for example, near my Java installation or in a utilities tools folder. The important thing is just to know where it is, because Eclipse will need to reference it. To create an application with the unfolding library, I import the unfolding app template with examples folder as a project. To do this, right-click in the Package Explorer and choose Import, and then from General choose Existing Projects into Workspace, and then find the unfolding app template with examples folder, select that, and click Finish. After the project is imported, I need to tell Eclipse where to find the native libraries for JOGL. This is the OpenGL code compiled for my operating system. To do that, right-click on the project, choose Build Path, and then Configure Build Path. And then, under Libraries, under the class path, click the arrow next to JOGL all.jar to open it up, and click on Native Library Location. Click the Edit button and navigate to the JOGAMP All Platforms folder. then the lib folder, and then click on the appropriate folder for your operating system. For me, that's Windows AMD 64. Click OK. This step connects the jar file to the native code it needs in order to run properly on your machine. Without it, your project might compile, but won't run correctly, especially when OpenGL is needed to draw the map. While I'm here in the Build Path dialog box, I'm going to select my installed JRE system library. When you first import this project, you might have a red X on JRE system library unbound. You'll need to edit that and click on Workplace Default JRE, and then Apply and Close. Now I can add my files to this project. I'll add my country rights class to the SRC folder. I'll add the CSV file to the project folder. Now, I've taken a choropleth example available in a tutorial on the Unfolding website and modified it for our data. The example loads in the country outlines from countries.go.json, which is included in Unfolding project. I'm going to open it as a text file, and you can see there's a country name, and then a polygon defining the country's border, and finally the ISO 3166 code, which will allow this program to find the correct country rights country and ask it for its alpha value so it can shade that polygon. This program uses a hash map data structure, which is something we haven't learned about, but if you're familiar with the dictionary type in Python, it's the same kind of data structure. It's a very efficient way to store and access data. Our countries are stored in a hash map by this program by their ISO code. I just modified the loading method and renamed it. Here it's called Load Country Rights from CSV, so that it would pull the correct data out of the CSV and instantiate a country rights object to store in the hash map. You certainly could do this with an array and a sequential search, but because the hash map is so much more efficient, I left this code in place. One other small change I made is I changed the map provider to Microsoft.Road provider because the old map provider was no longer available. This code is quite old, so some things are bound to need updating. Now here in the shade countries method is where we're calling the getAlpha method of our country rights class. For each country outline, this loop will access the correct country rights object and send it the getAlpha message to get the alpha channel, the transparency, of the color it's using to shade the outline. A color is specified as red, green, blue, alpha. You can see this color is all red, 255 in red, and zeros in blue and green, and then the alpha from our country. I'll run the program and you can see how this looks. There's Afghanistan. Remember that has an equality index of 0, so its shade of red is pretty transparent. And over in North and South America, most countries are doing pretty well with darker shades of red. We could change the map to shades of blue by changing the color to 00255, and then our alpha. I thought this was a fun way to use our country rights data, plugging our objects into an existing choropleth map generator. I hope you agree. In this video, we looked at how to fill an array of objects from a file. Put simply, you read the data from the file that corresponds to one object, so one record of data, and then use it to instantiate an object and store it in the next location in the array. We then looked at our sorting and searching algorithms on an array of objects. We can't directly compare objects in an array, so we need to be able to send a message to the objects in the array that allows us to search or sort. For example, an accessor for the name of the country allowed us to search for a country. A compare-to method for the equality index values allowed us to sort our array by the equality index. Finally, we took a quick fun side trip into drawing a choropleth map representation of our data using Unfolding. I hope you found this video interesting and helpful. As usual, I've included some auto-graded exercises in the description of this video so you can practice with this code, and the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.